Imagine a time, and it really wasn't that long ago, when artificial intelligence, AI, felt like it was always just around the corner. You know, we had these really clever algorithms, brilliant ideas, even some early neural networks that hinted at what was possible. But again and again, these systems seem to hit this fundamental wall. They can be smart, sure, but brittle, amazing in very narrow situations, but totally lost when faced with the real world, well, messiness. Then something changed, something huge, but maybe not obvious at first. And it wasn't really about a brand new algorithm, not primarily anyway, or some massive hardware leap. It was something else, something that unleashed this explosion of capability. It didn't just tweak AI, it launched the revolution we're in right now. Today, we're doing a deep dive into the rise of data. It's this often underestimated kind of ubiquitous force that truly became the engine, the jet fuel, for machine learning's incredible rise. Our mission today is to explore how that digital data explosion, back in the 90s and 2000s, driven by the internet, mobile devices, how it didn't help AI, but fundamentally change what AI is. It was the bedrock modern AI was built on. We'll be digging into some key questions here, like why do people suddenly start saying data is the new oil? What does that powerful metaphor, which can be a bit unsettling, really mean? How did massive data sets, things like ImageNet, become these huge turning points? How did they reshape AI research and what it could actually do? And what exactly changed about the algorithms themselves when they suddenly had access to this sheer scale, this unprecedented diversity of data? How did they go from just following instructions to, well, something like understanding? And maybe the biggest question, what are the consequences? Both the amazing benefits and the really tricky ethical problems that come with all this data. This deep dive should be a pretty fascinating journey right into the foundation of modern AI. And hopefully, you'll come away with a whole new appreciation for that silent ingredient, the data, that powers so much of your digital life. Those recommendations you get, the assistants you talk to, it's all built on this.
That's exactly right. The usual story about AI focuses on the algorithms, maybe the hardware getting faster, Moore's law and all that. But the huge leap, the transformation from AI being this interesting but often stuck academic thing into the technology that's everywhere now, that really started with data. Just unprecedented amounts of diverse data becoming available. That was the raw material, the training ground. It let those algorithms move from theory to practice, becoming these high-performing, surprisingly flexible systems. It was that shift, wasn't it? From trying to meticulously tell a computer how to do everything step by step to letting it learn for itself from experience.
Okay, so to really get the scale of this data revolution, we need to sort of cast our minds back, go back in time a bit, before this flood of digital info. Before all this fuel arrived, what did AI actually look like? What were the main hurdles? What problems were people trying to solve? And why did progress feel so, well, slow sometimes, almost stuck?
Right. In those early days, AI was, a very different animal than what we see today. It was mostly about what we call symbolic systems, and crucially, manual, explicit programming. The whole idea was you try to make a machine intelligent by painstakingly encoding human knowledge, rules, logic, directly into its code. Think of it like trying to teach someone to swim by giving them this massive textbook. Hundreds of pages on fluid dynamics, muscle movements, and then you expect them to jump in the pool and swim perfectly first time.
Right, you're just describing it with rules, not letting them actually feel the water.
Exactly. You're trying to capture something incredibly complex and nuanced with just a limited set of explicit instructions. Take computer vision in the 60s. You had pioneers like Minsky and Paper doing amazing work for the time. Their approach was basically, let's program the computer with rules. Rules for finding lines, edges, shapes, then rules for combining those shapes to recognize objects.
Sounds logical enough.
It does, but it didn't really work for general vision. The real world is just too messy, too variable. Think about all the ways an object can look different. Lighting changes, angles change, it might be partly hidden. You just couldn't possibly foresee and program enough rules to cover all that. It was like trying to, describe the exact taste of a really complex dish using only words. You just can't capture it all. People sometimes talked about a ladder of generality back then. Imagine each rung is a computing approach, and higher rungs are more flexible, more adaptable. Well, manual programming, defining every single step, kept early AI stuck way down on the lower rungs. And the core problem was deep. Most human knowledge, especially the stuff we use without thinking, our tacit knowledge, just couldn't be easily written down as explicit rules for a computer.
Like how you recognize a friend in a crowd,
or understand sarcasm.
Precisely. You can't just write a simple checklist for those things. It's intuitive. It comes from experience. So for decades, AI researchers were kind of like architects with amazing blueprints, but almost no concrete, no steel, no glass, just the plans.
So it sounds like this huge gap existed between the dream, the theoretical possibility, and what could actually be built. The engine was designed, maybe, but it just didn't have the right kind of fuel to really roar to life. What was that critical missing piece holding things back from climbing that ladder of generality?
Exactly. That missing piece was the input. Vast, varied, real-world input. The kind of input that lets systems learn organically find patterns themselves, instead of just executing what they've been told. A lot of the classic AI problems back then involved searching within a well-defined state space.
Like finding the best route on a map, or solving a puzzle.
Yeah, or playing chess, even. Problems where the rules are clear, the possible states are known, the goal is obvious. The computer can systematically explore the options within those defined boundaries. But that's a totally different ballgame from, say, recognizing a face from a raw camera feed, or understanding natural language with all its slang and ambiguity, or generating something creative. Those tasks don't have neat boundaries or simple rules you can program in. They demand an ability to pull out subtle patterns, to generalize well, to handle the sheer messiness of real-world data. And that ability was largely missing because there just wasn't enough data, enough experience for the systems to train on. The algorithms were searching all right, but often searching in the dark. Not enough clues, not enough examples to really make sense of the world in a flexible way, like that detective with no clues, yeah.
Okay, so we have the theories, some clever but limited algorithms, like that high-performance engine sitting there, but running on fumes, if running at all. What finally kicked things off? What opened the floodgates for this, well, absolutely essential flood of data? What turned the theory into something real?
It really was this perfect storm, wasn't it? A powerful mix of rapid tech advances and huge shifts in how we all behaved. First, and this is fundamental, you had the exponential growth in computing power. This wasn't just things getting a bit faster, it was relentless, transformative change. Moore's Law is the famous one, right? Computing power roughly doubling every couple of years, processors getting faster and faster. But it wasn't just speed. Critically, the cost of storing data and accessing it just plummeted, absolutely cratered. Faster memories, which you absolutely need to handle huge amounts of information quickly, became, well, the number is staggering, 10 trillion times cheaper over about 6 decades.
Hold on. 10 trillion times cheaper. That's not just cheaper, that's practically free compared to before.
It almost is, yeah. It fundamentally changes the economics.
To put that in perspective, that's like saying you could buy all the gold ever mined in history for, what, $1? Something like that?
Mm-hmm.
What does that kind of cost drop actually unlock? It's more than just making things affordable, right? It changes everything.
Precisely. That kind of affordability didn't just make storing data possible on a large scale, it made it almost inevitable. Why wouldn't you store it if it costs basically nothing? It meant companies could suddenly afford to log every click, every interaction, every piece of user content, turning these huge digital footprints into potential assets. Researchers could think about training models on data sets that would have bankrupted them just 10 years earlier. It flipped the script completely. Data went from being this scarce, precious resource to being abundant, almost a free commodity. That changed the entire economics of information. And layered on top of that cheap power and storage, you had the second huge driver, the explosion of digital data sources, especially from the 90s onwards, and then accelerating like crazy in the 2000s. The internet's role here is just massive. Can't overstate it. Suddenly, you had this unprecedented public library of text, images, audio, everything, growing constantly. For the first time, researchers, companies, anyone really, had access to this vast pool of real-world stuff they could collect and analyze, every website, forum, news article, potential raw material.
Like discovering a whole new continent full of resources just waiting.
Exactly. And then came the next wave. Mobile devices and social media. Think about it. Suddenly, everyone has a phone in their pocket, with a decent digital camera, always connected. Combine that with the explosion of platforms like Facebook, YouTube, later TikTok, and ordinary people started generating unbelievable amounts of unstructured data, nonstop billions of photos, videos, audio clips, text messages, posts, just flowing constantly, uploaded, shared, consumed. It was this huge behavioral shift. Our everyday lives, our experiences, our expressions became this readily available, seemingly endless digital resource. We all became, often without realizing it, data factories.
Okay, this combination, cheap computing, endless user-generated content, that sounds exactly like the moment when data is the new oil, became such a common phrase. It's a really evocative metaphor. Can you unpack that for us? Why oil? What are the deeper connections and the implications?
Absolutely. And it's a really useful analogy. The data is the new oil one, but it's also quite loaded because it reveals a lot about how data is viewed and used now. It's not just a catchy phrase, it points to real economic and power dynamics. So, first, the value part. Like crude oil, raw data isn't immediately useful, is it? It's messy, unstructured, needs processing. But once you collect it, clean it, refine it, using sophisticated algorithms, you can turn it into something incredibly valuable. Insights, predictions, what we now call computational intelligence. Just like oil fuels industries, data fuels AI. It drives everything from the ads you see to medical breakthroughs. Second, it really speaks to an extraction mindset. Scholars like Kate Crawford have talked about this a lot. The AI industry often takes this ruthless pragmatism towards data. Basically, almost any digital content, your photos, your texts, your clicks, sounds, videos, is seen as raw material to be acquired, gathered up, processed.
Often without really asking permission or thinking too much about where it came from.
Often, yes, with minimal context or explicit consent. The goal, building powerful AI, is sometimes seen as justifying the means of collection. It's very similar to how we've historically extracted resources like oil from the earth. And third, and this is critical, it highlights power and asymmetry. Think about oil historically. Control over oil reserves, drilling, refining. That meant huge geopolitical and economic power for certain nations and companies. Well, now, in a very similar way, control over massive, high-quality data sets concentrates enormous power in the hands of just a few big tech companies. This extraction logic, as Crawford calls it, echoes those older patterns. The raw materials, our digital lives, our creativity are gathered and refined by a powerful few, and the benefits often flow disproportionately to them, while the people creating the data see little direct return or control. So the so what here is huge. It means every time you interact online, every photo you share, every search you make, every video you watch, it can all potentially become raw data for AI. And that forces us to ask some tough questions, doesn't it? Who's really benefiting from all this data extraction? Why do certain stories about data, about how essential it is, get told and accepted? And what does it mean for society when a handful of players control the fuel for what might be the most transformative technology ever? It's not just tech, it's about power, economics, and it affects every single one of us.
Okay, so we've got this gigantic, ever-growing ocean of digital data out there, and the computers to handle it are cheaper than ever. But just having raw data, even tons of it, isn't enough for an AI to learn from, right? How did all this raw information actually start getting organized? How was it turned into something usable for AI systems? Is it all automated, or is there a big human piece in getting this data ready?
That's exactly the crucial step. Raw data is one thing, usable. Labeled data is another. You need to prepare it, clean it, and very often tell the AI what it's looking at. And this is where the development of these massive, meticulously labeled data sets became absolutely pivotal. They were the bridge. One of the biggest aha moments, a real turning point for AI, happened in 2012. A team from the University of Toronto used these new deep learning methods in the ImageNet competition.
Yeah, yes, ImageNet, that comes up a lot. What exactly is it?
So ImageNet isn't just a random pile of pictures. It's this huge, carefully curated data set built specifically for object recognition research. We're talking over 14 million images, sorted into more than 20,000 categories: tabby cat, container ship, lemon, you name it. And critically, humans had labeled these images painstakingly, saying, this is a cat, this is an airplane. The Toronto team's success using deep learning on ImageNet was stunning. They slashed the error rate compared to previous methods. It was so decisive.
That everyone else just had to switch.
Pretty much. By the very next year, 2013, all the top teams in the competition were using deep learning. It was a massive paradigm shift. That was the moment, really, when machines started to effectively see and interpret the visual world with the kind of accuracy and robustness we hadn't seen before. And it was that combination, powerful algorithms plus this huge labeled data set.
And presumably this wasn't just for pictures, right? This need for big labeled data sets must have applied across the board. Language,
Yeah.
sound.
Oh, absolutely. The principle was the same everywhere you needed AI to understand messy, unstructured data. The core insight was clear. Machine learning models, especially these deep neural networks, just get better and better with more data, more quantity, more diversity. The more examples they see, the more varied those examples are, the better they learn complex patterns, the fewer mistakes they make, and the better they handle new stuff they haven't seen before. Think about the sheer scale of training data we're talking about for today's cutting-edge AI. Image recognition, speech-to-text, translation, even playing complex games. They're trained on truly huge data sets. We're talking Literally, data sets with more cats than any one person has ever seen, more sentences than any one person has ever read, and more games than any one person has played in their entire life.
Wow. That scale is hard to comprehend.
It is, and it's that sheer volume of experience that lets these models develop this incredibly nuanced, almost intuitive grasp of their domain, way beyond what you could ever program explicitly. And you see this connection between model size and performance, too. Take large language models like GPT-3. These models have billions of parameters.
Parameters being like the knobs and dials the AI learns to tune based on the data.
Kinda, yeah.
Yeah.
They represent the learned connections, the knowledge stored in the network. GPT-3 had 175 billion parameters, and it was dramatically better, more reliable, more coherent than its predecessor, GPT-2, which had far fewer. That huge jump wasn't just a slightly better algorithm. It was proof of the power of scaling up both the model architecture and, crucially, the enormous amount of data it was trained on. More data, more parameters, seemingly more intelligence.
So it's clearly not just about passively scooping up data and dumping it into the machine. It sounds like there's this massive, often unseen human effort involved, preparing it, labeling it, refining it before the AI even sees it. Is that right?
Absolutely. You've nailed a really critical point there. Automation helps with collecting the raw stuff, sure, but a huge amount of the really vital work, especially the labeling and cleaning and refining, still relies heavily on human labor. It's often called the invisible work or ghost work behind AI. You read reports, for instance, about how cheap labor drives China's AI ambitions. This highlights the massive effort in data labeling. We're talking about armies of people, often low-paid annotators, sitting there meticulously drawing boxes around objects and images, transcribing audio, classifying text sentiment, basically teaching the AI step by step. This is a car. This is a stop sign. This person sounds angry.
So AI isn't learning entirely on its own. There are humans guiding it at that fundamental level.
In many supervised learning tasks, yes. This reliance on human annotators points to the hidden human cost, the global economic factors behind the sleek AI interfaces we use. It's a reminder that even the most advanced AI often stands on the shoulders of countless hours of human work. And even when you have vast amounts of data, quality and relevance are still huge issues. You run into something called the curse of dimensionality.
Sounds ominous.
It basically means that just adding more data points or more features doesn't always help. Sometimes it can actually hurt performance if the extra data is irrelevant or noisy. Imagine trying to find a specific book in a library. If someone keeps adding thousands of completely unrelated books to the shelves, the library gets bigger, sure, but it doesn't help you find your book. It might even make it harder.
Right. It obscures the signal.
Exactly. Too much irrelevant data makes it harder for the AI to spot the real patterns. And there's also the issue of sampling noise, which researchers noted early on. In big, real-world situations, you can't possibly show the AI every single example. You have to use a sample, a subset of the data. But the way you sample can accidentally introduce noise or biases that weren't in the original full data set. This noise can mask the true patterns the AI needs to learn, so it all points back to needing not just lots of data, but good data. High quality, representative, carefully curated data. Quantity matters, but quality and smart organization are just as vital.
Okay, so we've got this incredible fuel source data collected, organized, labeled through these huge pipelines, often with a lot of human help. With this massive engine of experience now available, what could AI systems suddenly do? What capabilities were unlocked that were just unthinkable back in that searching in the dark era?
The absolute core shift, the really revolutionary part, was AI gaining the ability to learn beyond explicit programming. It stopped being about developers trying to anticipate every possibility and write a rule for it. Instead, systems started observing, inferring patterns, figuring things out for themselves just by crunching through massive amounts of data, developing their own internal models of how things work. A fantastic example of this learning on its own was back in 2014. Google DeepMind trained an AI to play old Atari video games, Pong, Breakout, Space Invaders.
Oh, yeah, I remember that.
And the amazing part was it achieved superhuman performance without being told the rules or any strategies. It just got the raw pixels from the screen, the score, and control of the virtual joystick. Through trial and error, reinforcement learning, processing game data, seeing what actions led to higher scores, it just figured it out.
Just by playing.
Just by playing and learning from the data of its own experience. It was this powerful demonstration of data-driven, self-directed skill acquisition. And then, of course, came AlphaGo in 2015-16, Mastering Go. That really captured the public imagination.
Because Go was seen as this intuition-heavy game. much harder for computers than chess.
Exactly. The number of possible moves is astronomical, way beyond what brute force search could handle like in chess. Evaluating who's winning is also incredibly subtle. Experts thought it would take decades longer for AI, but AlphaGo learned first by studying a huge number of recorded human Go moves. So it learned from existing expert data. But then, the crucial part, it played against itself millions and millions of times, generating its own massive data set of games, learning from its wins and losses against slightly different versions of itself.
So it became its own teacher, essentially generating its own data.
Precisely. And that self-play, fueled by this internally generated data, pushed it to truly superhuman levels. It even made moves that surprised top human players, moves they described as creative or beautiful. People like Yann LeCun, a real pioneer in deep learning, often emphasize this. AI learns by observing the world, much like babies and humans learn. It's this data-driven observation that helps machines build these rich internal models of reality, which is likely key to developing things like common sense, something still largely missing, but essential for reaching artificial general intelligence, or AGI. It's about learning from experience, not just rule books.
So it's moving beyond just solving complex, defined problems like games, towards actually understanding and interpreting the messy, real-world images language. That feels like a much bigger leap.
It absolutely is. This data-driven approach was the key that unlocked success in all sorts of unstructured perception tasks where older AI methods really struggled. Things without clear rules, involving ambiguous sensory input. Take image interpretation. Those convolutional neural networks, CNNs, trained on ImageNet and similar datasets. They didn't just learn to match patterns, they learned to detect features hierarchically. Like the early layers in the network might spot simple things, edges, colors. Middle layers combine those into more complex shapes or textures.
And deeper layers recognize bigger things, like faces or objects.
Exactly. Eyes, noses, wheels, eventually whole objects or scenes. And the really mind-blowing part was that these concepts often emerged from the data. Neurons deep in the network would start responding specifically to images of cats or dogs or cars, even though no one explicitly programmed the definition of cat into the system. The categories self-organized just from exposure to the labeled data. And you saw similar breakthroughs in processing human language, right? Speech recognition, machine translation. By training on billions of words, hours and hours of spoken language, these models started grasping grammar, meaning, context, nuance, in a way rule-based systems never could.
Which is why we can talk to our phones now and they mostly understand us or get instant translation.
Exactly. That's all powered by models trained on vast linguistic data. And more recently, we're seeing steps towards cross-domain flexibility. DeepMind's Gato model was an interesting example. It was a single neural network, one model that could do a whole bunch of different things. Play Atari games, chat, describe images, even control a robot arm.
The same model doing all that.
The same core model, yes. It suggested that maybe exposure to really diverse, multimodal data could lead towards more general, human-like intelligence that isn't just locked into one specific task. A broader data diet leading to broader skills.
Beyond these huge breakthroughs, how is this data-driven learning showing up in more everyday ways? You mentioned education earlier. That feels very direct, very personal.
Right. Data is absolutely fundamental to personalization, and education is a great example where it can have a huge positive impact. Think about AI tutoring tools, like Khan Academy's Khanmigo. Khanmigo acts like an adaptive tutor. It's constantly analyzing data from the student, how they're doing on exercises, what concepts they're struggling with, what questions they ask, how quickly they progress. This rich, real-time data set lets the AI figure out exactly where that student needs help, maybe even before the student realizes it themselves.
So it tailors the experience.
Precisely. It can offer personalized suggestions, explain things differently, give targeted practice, keep the student right at their learning edge, challenged but not overwhelmed. This kind of one-on-one adaptive instruction used to require a dedicated human tutor for every student. It was an ideal, but totally unscalable. AI, fueled by student data, is making that personalized approach much more realistic and scalable. It's moving education away from the old one-size-fits-all model.
Okay, the picture you're painting is really impressive. Incredible progress, huge potential, capabilities that touch almost everything we do. But it feels like there has to be a catch. With this much power, this much influence, relying so heavily on data, there must be significant downsides, big challenges, serious ethical issues. It can't all be smooth sailing, can it? It feels like a double-edged sword.
You're absolutely right to bring that up. It is a double-edged sword, without a doubt. While data fueled the revolution, its sheer abundance and the ways it's often collected and used led straight into some really deep ethical waters, particularly around bias and discrimination. And these aren't just theoretical worries, they have real harmful impacts on people. The issue of algorithmic bias is, well, it's baked in many ways. When you train AI on these huge data sets, often scraped indiscriminately from the internet, think of something like the LION 5B dataset, massive but reflecting the web, warts, and all the AI learns the biases present in that data.
Because the internet itself reflects our societal biases.
Exactly. Inequalities, stereotypes, historical prejudices, they're all online. And the AI learns from that flawed mirror, and sometimes it even amplifies those biases. We've seen countless real-world examples, unfortunately. Text generators producing racist or sexist content because they learned it from the web text they ingested. Facial recognition systems being less accurate for women or people of color because the training data wasn't diverse enough. That's not just an error, it's a bias with real consequences. There was even that case of AI cameras in delivery trucks wrongly penalizing drivers because the system misinterpreted something due to biases in how it processed visual data under certain conditions.
And these aren't trivial applications. We're talking about systems used in hiring, loan applications, criminal justice, healthcare.
Precisely. Child welfare assessments, predicting recidivism, diagnosing diseases. Bias in these systems can perpetuate and even worsen existing societal inequalities. It's a huge problem. And beyond bias in the data itself, there's the issue of what AI can generate. The sheer volume and potential deceptiveness of AI-generated content threatens our basic trust in information. This is sometimes called the liar's dividend.
The liar's dividend.
Yeah, the idea is if AI can create convincing fakes, text, images, audio, video, then people might start disbelieving everything, even authentic content. The old seeing is believing idea just breaks down. If any image or video could be fake, how do you know what's real? It makes it much harder to have informed public discourse, fosters cynicism, and erodes trust.
And that ability to generate fake content leads directly to things like deepfakes, which seem incredibly dangerous and personal.
Indeed, deepfakes and AI-generated disinformation are a serious, immediate threat. We hear a lot about non-consensual sexualized deepfakes, which are horrific and have genuinely ruined lives. There was the Kaylin Heyman case in the US, which actually led to a specific law in California targeting this kind of abuse. But beyond that, there are huge concerns about disinformation campaigns using AI to generate fake news or manipulate videos to sway public opinion or interfere in elections.
Can AI really change election outcomes?
Well, some argue that direct vote manipulation might be harder than feared. People are often skeptical. But the broader damage is that erosion of trust we just talked about. That's a definite societal cost, making it harder to agree on basic facts. And sadly, the misuse is already happening widely. We know AI is being used extensively for financial fraud, creating fake identities, scamming people, and horrifically, it's being used in intimate image abuse, including the generation of child sexual abuse material, which organizations are finding online. These aren't future risks. They are tangible, devastating harms happening right now because of the misuse of these data-driven tools.
So we have issues with the output bias, fakes. What about the input? The data these systems rely on day to day. How secure is that? How vulnerable is it to being messed with?
That's another critical vulnerability. Data security and manipulation risks. AI prediction machines are fundamentally dependent on their data, the data they're trained on, the live data they receive, the feedback they get. The old computer science saying garbage in, garbage out is truer than ever for AI. If the data is bad, biased, or deliberately corrupted, the AI's output will be bad too, often dangerously so. And these systems definitely have vulnerabilities. Hackers could potentially feed an AI system bad data to make it malfunction, or even subtly tweak its internal model. Researchers have shown, for example, how you can trick image recognition AI. They inserted random-looking images into videos for just fractions of a second, totally invisible to a human eye, but it completely confused the AI, making it misclassify the whole video.
Wow, so you could potentially fool self-driving cars or content filters.
That's the concern, yes. These adversarial attacks could have serious consequences in safety-critical systems. And think about personalized systems. If an AI managing a diabetic's insulin is fed the wrong patient ID or faulty blood sugar readings,
The consequences could be fatal.
exactly. It highlights this absolute non-negotiable need for data integrity. The data streams feeding these AI systems have to be robust, secure, and uncorrupted. The stakes are incredibly high.
This all paints a picture of an urgent need for, well, for rules, for careful thought about how data is collected, used, secured, what is being done or what should be done about ethical oversight and regulation. It feels like the tech is racing ahead of the rule book.
The current situation is definitely complex and messy, frankly.
Right.
As we discussed, many AI companies built their foundational models using vast data sets scraped from the web, often without explicit permission from creators, and they frequently keep the details of these data sets secret.
Which makes it hard to check for bias or other issues, right?
Right. Extremely hard. If you don't know what's in the training data, how can you audit it effectively? And legally, it's all over the map, globally. You've got the European Union taking a pretty strict approach with GDPR and now the AI Act, leaning towards requiring permission or clear, fair use justifications for using data in training. Then you have the US, which has been more hands-off, sort of innovate first, ask questions later, relying more on lawsuits after the fact if harm occurs. And then places like Japan have said AI training generally doesn't violate copyright, basically opening the door to using almost anything. This inconsistency makes it really hard to have global standards. But there is a growing chorus, a rising tide of calls for regulation, even from within the AI field itself. You have pioneers like Yoshua Bengio arguing for open debate, for balancing innovation with safeguards. And then there was that widely publicized Pause AI letter signed by Bengio, Elon Musk, Stuart Russell, many others, calling for a temporary halt on training the most powerful systems.
To give regulation a chance to catch up.
Essentially, yes, to develop robust frameworks, maybe similar to how we regulate nuclear power or genetic engineering, other powerful technologies with potential risks. The underlying message is clear. This data-driven AI is incredibly powerful, maybe transformative, but we can't just let it run wild without serious ethical guardrails and regulations to steer it towards benefiting humanity and mitigating the very real harms. Hashtag tag outro living.
Well, our deep dive today has really hammered home how that explosion of digital data, everything from web pages to your phones, photos, and interactions, wasn't just incidental to AI's progress. It was the absolute engine of experience, the jet fuel that launched machine learning into the era we're in now. We've seen how all that data, combined with cheaper, faster computing, let AI learn, see, understand, and personalize things in ways that honestly felt like science fiction not that long ago, but are now just part of our daily lives.
Absolutely. But it's also clear this journey into data abundance is far from over. And it leaves us with these huge opportunities, yes, but also these really critical ethical responsibilities we just can't ignore. The very same power that lets AI achieve amazing things, mastering Go, tutoring students also carries these built-in risks: bias, misuse, security holes. Navigating this requires constant attention, real engagement from everyone, and a commitment to ensuring these tools actually help us.
So as we all continue generating and consuming more data than ever, and as AI gets even better at processing it, here's something to think about, a provocative thought maybe. In a world where data is clearly so essential for intelligence, what might the next kind of data be? What new forms maybe from our own biology, our collective thoughts online, maybe data from purely synthetic virtual worlds? What will fuel the next AI revolution? And maybe more importantly, how will we make sure this time around that the collection and use of that data truly serves humanity's best interest, protecting us, fostering real progress, and not just, feeding our worst impulses or concentrating even more power? Something to ponder.